Now, till now we were doing theoretically. We were understanding that alcohol is acidic in nature. In your exams, you will be asked that show by the help of chemical reaction that alcohol is acidic in nature. So the reaction is in front of you. In a screen you can see. When alcohol reacts with any metal like sodium, aluminium, it releases hydrogen gas, you can see. Like C2H5OH plus 2Na, you will give you what? C2H5ONA, that is sodium ethoxide, and hydrogen gas is released. The release of hydrogen gas, you know that, proves that alcohol is acidic. Because release of hydrogen gas proves that alcohol, any substance acidic. Like in the lower classes you have done it. Zinc plus HCl gives ZnCl2 and H2. This proves that HCl is acidic in nature because hydrogen gas is released. So here also same thing. Alcohol when reacts with sodium gives sodium ethoxide and hydrogen. So it proves that alcohol is acidic in nature. Now next one is we have taken tertiary alcohol. When it reacts with aluminium, it forms aluminium tertiary butoxide. You can see, and water is released. It proves that alcohol is acidic in nature. The next reaction also, that ethyl alcohol reacts with sodium hydride. You can take potassium hydride, sodium hydride, calcium hydride, anything you can take. Again you can see it forms here sodium ethoxide and hydrogen gas is released. The release of hydrogen gas proves that alcohol is acidic in nature. Now remember that alcohol acts as a Bronsted acid. Got it? Why? Because it donates a proton to a strong base. Alright, it acts as a Bronsted acid. You have read it. Bronsted law is as concept of acids and bases. Acids, what is Bronsted acid? Which gives H plus ion, which is a proton donor. And what is a Bronsted base? Which is a proton acceptor. So here it is a proton donor, it gives H plus ion. So here alcohol acts as a Bronsted acid. Got it? Because it donates proton to a strong base. Got it? Any strong base like NaOH, KOH in this way, or sodium oxide, potassium oxide, there is also a base. Got it? And hence what it forms is that it forms a conjugate acid and a conjugate base. Conjugate base is what? That is alkoxide ion. We can say that. Clear? So in this way. Now next is we will see some more reactions. That is we can see that here alcohol reacts with a Grignard reagent. Over in alcohol you can see over the red mark I have given here del minus, over oxygen del minus, and over H plus del plus. Similarly in Grignard reagent over R I have given you that is nothing but del minus, and over magnesium I have given you del plus. So that R and H, that is rather I have given R dash there in Grignard reagent. R dash and H reacts to form what? Alkane, because opposite charges they will react. From alcohol H, why it is H? Because H is positive. And here in Grignard reagent R dash is negative. Okay, so they react to form alkane and you are getting that is an addition product, you are getting it. Got it? So when alcohol reacts with Grignard reagent, it gives you what? It gives you alkanes. Alkanes are being produced when alcohols reacts with Grignard reagent. Like let us say CH3CH2OH when reacts with CH3MgBr. Got it? It gives you what? Methane CH4, and you get an addition product MgOC2H5, and another bond is with Br. Okay, so in this way this also proves that alcohol is acidic in nature because H plus ion is released, you can say that. Now the next one is very important, esterification. Esterification reaction. Now what is esterification? See, remember that when any carboxylic acid, generally monocarboxylic acid we take it, when it reacts with alcohol, got it, in presence of concentrated sulfuric acid which acts as a dehydrating agent, remember that, concentrated sulfuric acid, we get esters. Got it? And water is released. As we have taken conc H2SO4, then only the reaction is taking place. Remember that. Without conc H2SO4, reaction will not take place. Why? Because water will not be released. Here concentrated sulfuric acid, what I said you, it acts as a dehydrating agent. See the reaction on the screen, RCOOH, that is your carboxylic acid. When it reacts with R-OH, alcohol, so water is released there. You can see I have given you the red mark, you can see very clearly in presence of conc H2SO4. So conc H2SO4 is very much necessary for carrying out this reaction. Will give you ester RCOR- plus water. You can see the water is being released. Clear? So this process is known as esterification. This process is called as esterification. Now remember that here one more thing I will tell you. Instead of conc H2SO4, you can also use HCl gas. Of course here conc H2SO4 acts as a dehydrating agent, got it, but also at the same time it acts as a catalyst. So instead of conc H2SO4, if I use HCl gas, listen carefully, as a catalyst, even it will act as dehydrating agent also, because you know that HCl has got strong affinity for water. You have read it in the lower classes, especially ICC student, they have studied that 452 volumes of HCl is soluble in 1 volume of water. Alright, so it can also be used. So the name of the reaction is Fischer-Speer esterification. Fischer, Fischer, Speer, Speier, Speier, Fischer-Speer esterification if HCl gas is used instead of conc H2SO4. Alright, only this much, the name is changing, nothing else. We can say that is also called as esterification. You can do that. Clear? So in esterification, if you want that the reaction should be carried out in the forward direction, then what you need to do? You need to remove water immediately from the site of the reaction. You need to remove, or the concentration of the reactant has to be more. We can say that. Then only the reaction will be proceeded in the forward direction. Got it? Now, one thing more before going to the mechanism, I'll say you that rate of esterification decreases with increase in size of the alkyl group. Alright, remember that the rate of esterification decreases with increase in size of the alkyl group attached to COH group of acid and OH group of alcohol, because in both cases you are having alkyl group. In acid also we are having alkyl group, and alcohol also we are having alkyl group. So listen carefully, rate of esterification decreases. Why? Due to steric hindrance, bulky group. When the alkyl group will be bulky, bigger, then steric hindrance is going to take place. You know what is steric hindrance? The electron cloud will repel one another when they will come closer to each other. Got it? Electron cloud of whom? Electron cloud of alcohol and is what you can say acid. They will repel one another when they are coming closer to each other. So due to increase in the steric hindrance, what you can say is that the rate of esterification will decrease. Rate, you understand that how faster ester is going to take place. So it will be slower. The rate will become slower and slower. Means if you take methyl alcohol, it will be faster. If you take ethyl, slower. If you take isopropyl, slower. If you take tertiary butyl, slower, still slower. So methyl alcohol is, the rate will be more than ethyl alcohol, then isopropyl alcohol, then tertiary butyl alcohol, we can say that in case of alcohol. Same thing in case of acid, the rate will be maximum in case of formic acid, then acetic acid, then you can say that propanoic acid, then you can say butanoic acid. Got it? In this way. Or you can say that is nothing but CH3 whole twice CHOH. What is CH3 whole twice CHOH? It's nothing but isopropanoic acid. Got it? And that is CH3 whole thrice COH is nothing but tertiary what you can say butanoic acid. We can say that. Clear? So in this way, what we find is that more the number of alkyl group, more bulky the alkyl group, rate of esterification is decreased because steric hindrance increases. Mind it. Okay, in this way. Now, one more what you can say esterification I have given you, that is you can use an acid also. You can use an acid, you can use acid anhydride, you can use it and you can carry out the esterification. Like here you have used acid chloride, RCOCl, plus again alcohol in presence of pyridine. Here pyridine acts as a basic catalyst. C5H5N, we can say that. Got it? That is pyridine. Clear? It gives you ester RCOR dash plus HCl is being released. Clear? Pyridine acts as a basic catalyst. You can use acid chloride also. Instead of acid, you can use acid chloride and alcohol. Same thing, you can see the charges I have given you there. If you do the charge separation, it becomes easy for you. Understood? So do the charge separation and write the reaction. It becomes easy for you. RCOCl, you can see C over CO, that carbonyl group, carbon is positive charge and chlorine is negative compared to it, electronegative. Similarly, in R-OH, O is more electronegative than H plus ion. So you get in esters. I hope it is clear to you, this particular thing. Clear? Thank you very much.